Hello everyone, I'm Nura Mansour. I'm a molecular biology and genetics student at Bilkent University. Today I'll be presenting my Physics 101 lab project. And in this project, I'll be measuring the gravitational constant using variable length pendulums and two different mass objects. So I will be validating the laws of gravitational force under variable conditions, where the strings of the pendulum will be different. I'll be using three different variable lengths, and I'll be using two objects. For this experiment, I will have two hypotheses. The first hypothesis is that as the length of the pendulum gets longer, the more accurate the gravitational constant will be measured. And my second hypothesis is that the masses should not be affecting the constant calculation. According to the gravitational law, the accuracy should not be affected, neither should the calculation of the gravitational force while using different mass objects. For this experiment, I'll be using the following equipments. I'll be using a duct tape of mass 13.3 grams, a small rock of mass 25.6 grams, and I will be attaching those to the strings of different lengths, 20 centimeters, 30, and 40 centimeters. I'll be using a stopwatch to calculate the period time of the objects in the pendulum, and I'll be using a measuring tape to measure the strings, and I'll be using a frame to hang the pendulum from, which I will be using from the physics lab itself. The equation I've used to support my hypothesis in this experiment was the time period equation, where T stands for the time period of the pendulum in seconds, and L stands for the length of the string. We can derive the G constant from the main equation and apply the variable lengths of L. In this equation, it shows that the G constant only is relying on the length of the pendulum and the time period in seconds. And I will also use the percentage error equation to compare the calculated experimental G constant with the theoretical value, which is supposed to be 9.81 meters per second square. Now I would like to present the calculated data that I've calculated from my experiment in the lab. And it shows that the percentages at the length of 20 and 30 were significantly more than the percentage error that was presented at length of 40 centimeters of the string of the pendulum, where at the length of 40, the calculated percentage error was approximately 0.1 for both objects. From the first graph I've plotted of the period against the length L, we can detect that both objects were approximately taking the same amount of time to complete one period of T, which ranged from 0.95 or approximately 1 to 1.25. From the second graph of gravitational acceleration plotted against the length, we can detect that at 40 centimeters of length, the gravity acceleration constant was able to be predicted and calculated more accurately than the ones at 20 centimeter and 30 centimeter. And that might be due to the relative reduction in timing error and reduction in the impact of the initial angle and the air resistance that falls on both of the objects. And by this, we can conclude that both of our hypotheses were proven correct due to the resulted collected data and the plotted graphs. Thank you for listening.